Hi, welcome to the Friday Transportation Seminar at Portland State University. My name is Chris Monsieur. I'm a faculty member in the Department of Civil and Environmental Engineering. We're very pleased today to have a visitor from the University of Idaho, Mike Lowry. He's an assistant professor in civil and environmental, or civil engineering there. Or do you have the environmental?
Just civil.
Sorry, just the civil engineering department. And he's going to talk today about GIS tools and how they relate to bicycle planning. So I'll turn it over to Mike. Welcome.
Great. Thanks. Good to be here. This is a photo down of the small town where I'm from. University of Idaho is in Moscow, Idaho, up in northern Idaho. And so it's always fun to come. I came with my daughters here. And so when we pulled in over and we saw the cityscape, my daughter said, "Dad, is this a kingdom?" And I thought, that's a weird thing to say. And I said, "What do you mean?" And then I realized she's looking at the skyscrapers. And she said, "Is this the kingdom of Arendelle?" Which is from Frozen, if you know what that is. So all little 5-year-old girls would know the kingdom of Arendelle. So Moscow, Idaho isn't a kingdom, but it is a nice place. And if you ever come up, great place to visit. And then 9 miles away is Pullman, Washington, which is Washington State University. So the two universities make a nice university community. I'm going to talk about, they asked me to just come and share the work I've been doing the last few years. So this is sort of a showcase of some GIS tools that I've been creating. And I've made others as well, but these are 4 that kind of identify and distinguish the work I've been doing. So the first tool is calculate bicycle level of service, and then calculate community-wide bikeability, estimate bicycle volumes, and then assess dangerous situation exposure. So the first tool, calculate bicycle level of service. With each of these tools, I'll give a little bit of background. This project was actually funded by the Idaho Transportation Department. They wanted to create a GIS tool for assessing bicycle suitability. And the first step we did is we wanted to look at that term suitability and get a good sense of what it means. And we found in the literature that people were using a lot of different terms: bicycle suitability, bikeability, bicycle friendliness. They're using them interchangeably, different authors, and sometimes to mean the same thing, sometimes to mean different things. I'll try and, I am a professor, so I'm sort of used to trying to get some audience participation, so I'll see if we can do a little of that today. What would you think is the difference between these terms? How would you think? Have you heard these terms before? What do they mean to you? Anyone? When you heard the word bikeability or something, what does that mean? Or do you think they're all the same? Have you ever thought of a difference between them?
I would assume they were the same.
You assume they're the same? Well,
I think that bikeability relates more to the layout of the city, the design of whether there are facilities, bike lanes, protected bike lanes, things like that. Bicycle friendliness would probably be, I relate it to more of like the local culture and people's familiarity with bicycles on the road.
Yeah, great. So that's exactly what we decided to do. We're thinking the same lines as you. So we decided with this definition, that bicycle suitability, and those of you who, this morning I went to a master's thesis defense of Nick Foster, or Forster? Foster. Nick Foster. And he talked about, he was also calling it level of service or quality of service. And so bicycle suitability is the perceived comfort and safety of a segment of a bikeway, of a street or a trail. And then bikeability then is that idea of the whole network and then getting to destinations. And then bicycle friendliness is all aspects of bicycle travel. The culture, do people accept you? And the same idea in the paper that we published on this, we also suggested that this could be used for walking. So you could have a street that is suitable for walking. You could have a community that is walkable, meaning there's places to walk to that are worth walking to. And then it's also pedestrian friendly, meaning people don't honk at you when you're walking around. And so that was the first step we did. It turns out there's been a lot of research on bicycle suitability and not so much on the other two. The League of American Bicyclists are kind of the only ones that actually touch this bottom one. But here's just an example of all the research that's been done on bicycle suitability. And this is a big list, but I just wanted to show it to, and there's even more than this. But all the way back to 1987, Davis developed a bicycle safety index rating. And then there's been others since then, all the way down to the one that I'll talk about the most, which is the bicycle level of service. But you see some of these bicycle quality index, a couple of them had that name, bicycle level of service. And then even since the highway capacity manual's level of service, there's been a new one that's came out by Peter Firth, and it's the level of stress. And then today, this morning, I went to the one that Nick and Chris Bonsier have done, and they didn't have an acronym for it, so I told them I'd call it the PLLOS. So, but Nick wasn't able to attend today. He said he's visiting with family this afternoon. So what do these do? What are these different things? They're some way to assess the quality of service or the perceived comfort and safety of a segment of roadway. And then you could maybe map that. Here's an example of suitability for bicycling, and you see how different colors are giving how suitable all of the streets are for bicycling. This was probably done just on expert opinion. I don't even think they used any specific method. It was just sort of made up. And in some ways, I actually think that that's maybe a better way to do it. We can talk about that later. But here's some of these methods. I got the acronyms up there again. But what they do is they take attributes of this segment of roadway. And so, for example, the bicycle stress level has 3 attributes. And you put these into an equation, and then it spits out a rating of good, great, and excellent, something like this. So the bicycle level of service, which was, as I started to say, is in the highway capacity manual and is considered sort of the premier method right now. It takes 10 attributes, these attributes, width of the lane, and so on and so forth, and then spits out a rating. And this is the equation of how it works. And again, I would love to have a long conversation critiquing this, because I think it's, this was sort of silly in some ways, because it's done by all this numerical methods of getting this. But you plug all that into the equation, and then you get a level of service A through F. And so that's how that equation works. And then just for illustration of a different method, which I think in some ways makes a little more sense just because of the simplicity of it, this is the bicycle suitability score. This was developed in Texas. And the way it works is you look up in an index table certain information like traffic volume, shoulder width, and then you get a number, and then you just add those up, and then you get a total score, which gives you some interpretation of how bicycle suitable that segment is. Here's another one that I like. This is the bicycle suitability assessment. This was developed about 10 years ago, and it was intended mostly for citizen volunteers to go out, and so it's sort of done in a format where you just sort of circle things and then fill it into an equation, and then in the end you get a bicycle suitability score. Again, a good method. But we were, as I said, this project was focused on the bicycle level service, which is in the highway capacity manual. And I have a video just to illustrate how this tool works. So I think I'll go here. Start with calculate bicycle level service per street. I'll pull in from the example data the street shape file. So I click on the tool and I open it up. This time it's showing the help. You can hide the help or show the help by clicking on that button. And this is the overall what the tool is going to be doing. And then when you click in each field here, the help changes and it provides information for that particular piece of input or output. So going back to the first piece of input, it wants the shape file, the street shape file. And then it wants to know the attributes associated, the 10 attributes for calculating bicycle level of service. Well, again, I've already named them the default values, which it was looking for, WOS. But I could have named them anything, and then this is where I tell the tool to find that field. Since everything has the default value, I'll keep it that way. I'll click OK and run the tool. It's running the tool with these notes. And you see it took just 3 seconds to run that tool. Here's the output. It has color-coded all of the streets. If we look in the legend up here on the left, it shows that from A to F, that's what these colors represent. And now I'm going to go to the output to see what it did. And it created 2 new fields, the bicycle level service score and then the bicycle level service text, which is the letter grade. Okay, so that's a pretty basic tool, but I'm going to show 4 of those, and they'll get more complicated as we go on. But I also debated bringing my own computer, and they suggested I bring USB. So I thought, okay, I'll do a video then. That way I can show you these tools in action. So that one's pretty simple. What we did is we just coded that equation in an ArcGIS tool. And so one thing maybe to take away from my presentation is if you're not familiar with ArcGIS, it's a good thing to become familiar with, because it's really great now. You can code it up really easily in Python and make your own tools. And so that's what we did with that one. Fairly simple. it gives an output like this, and then what you could do then is maybe start looking at scenario analysis by looking at the percentage of miles for each bicycle level of service. So this case study, by the way, is for Moscow, Idaho, all of the streets of my hometown. And there's a couple scenarios that have been proposed by the Transportation Commission up there. So just looking at, well, under different improvement scenarios, what does the percentage of level of service A through F, how would it change? So the next tool then I'm going to be talking about, to lead into that, let's just talk about this for a second. So let's say that a street has great bicycle suitability, but then the question is it useful in going anywhere, right? And so that's where we developed a new tool and a new assessment method, which we call bikeability, community-wide bikeability. So that's this next tool that I'm going to go over. And I understand that you are required to ask questions, so feel free to ask those during my presentation as well. You don't need to wait till the end if you have any questions. Okay, so this next tool, again, is going to focus on bikeability. And the idea here is that it's not just the segments, but the whole network. And then how do they connect destinations? Can you get to important destinations with good bicycle level of service? And so here's what the output will look like. I'll show the tool running. I'll run the tool in a second. But what we did is we take all of the destinations just in a GIS file, and then all of the bike lanes and bike trails, and each of the analysis zones, which are the squares, are getting a bikeability score, which is kind of like walk score. They do actually have bike score now too, which is a similar. We just have a sort of a different approach with our tool that is saying how bikeable are you to all of these destinations. And so along this graphic shows that along some of the bikeways, along some of the trails, there's better bikeability. And then also where there's a lot of density of destinations, there's also good bikeability because there's lots of destinations there. And so I've got a video for that as well. And it's on YouTube, but I'll click to it here. Okay, well, here's the bicycle level service for all of the streets in the city. But what if I want to go to the various destinations? Is it bikeable to get to those? That's what the term bikeability is referring to. So let me bring in some destinations. I could choose any destinations, but for example, that I have the grocery stores in the city of Moscow. So there they are. There are actually only 4 grocery stores in Moscow, and this 5th grocery store is one that's proposed. It's not there right now. And we want to know, is it bikeable to get to these grocery stores? If we lived in a residential area, say in this neighborhood or any neighborhood, how bikeable is it to these grocery stores? So the next thing we need to do is bring in some analysis zones. And this could be a parcel file, or it could be just some zones that were created. And so that's what I have here. These are the zones that we're going to do the analysis for to calculate bikeability. We're going to run the tool, calculate community bikeability. And here it explains how the tool works and what the output's going to be. And the first thing it wants to know is the bikeway network. The bikeway network actually is streets and shared use. And we'll go to that bikeways, streets and pathways. And now it wants to know where's our analysis zone. We're going to go to these analysis zones. And then it wants to know where are the destinations. And again, the destinations are those grocery stores. Let me go back and open up that attribute table. So here are the grocery stores. There are Winco, Safeway, Co-op, and Rosars. Those are existing. And then there's this 4th grocery store, which is proposed, and it's not existing. Well, what we're going to need to do is associate points with each destination. So we'll give equal points to all the grocery stores, but we could give more points to a particular grocery store if we wanted. We'll give equal points to all of them, and we won't give any points to the one that's not existing in the current condition. And in the proposed condition, we'll give equal points to all of them, including the new proposed grocery store. So you see here, it's asking for that file. This is the destinations file. And then it's asking for the destination points. Click on this, and we'll go to this temp folder, which I created, and we'll call this bikeability, and we'll make it scenario 1. And we'll click on that. We'll hit OK, and the tool starts to run. Okay, this tool is just about finished running. It's finalizing the output now, and in a moment it will provide the output there. It's completed, And on my computer it took 4.5 minutes. On other computers it might take up to 15 minutes. So let's look at the output. Let me close this. What it's doing is it's shading with a darker color the zones that have better bikeability, and it's scaled from 0 to 100. So here in this area, not surprisingly, the bikeability is quite high because it's close and easier access to the 4 existing grocery stores, the best bikeability being about in the middle. Now further on the edges of town, bikeability is worse because it's a longer distance to get to any of the 4 grocery stores. So now let's turn that off and run it again. What we see here is the same output that I've clipped and put into PowerPoint. And now, when I click on this image, this second image, this I'll is just scenario pause that 2 one there. with the new.
So I made these videos in order to show my tools through YouTube, but figured it was a good way to also do this presentation. Yeah. So this one's then showing that bikeability improved by adding a new grocery store, and the video and also the paper associated with this talks about you can also improve bikeability by adding new trails or new bike lanes that would improve access to destinations.
So just a clarification. So is this really just talking about the accessibility to get to the actual bike lanes, or is that just from your starting point to the destination that it's actually I guess more bike accessible?
Yeah, essentially the definition of bikeability that I'm using here is accessibility by bicycle. Mm-hmm. Good question. So I'll move on to the next tool, unless there's another question or anything. So I'm zipping through these pretty good.
Last name Holloway. Long-term objectives and goals for this is that essentially someone can potentially go online and do like bicycle trip planning, say like if they do with bicycles right now. Is that like what you're envisioning?
Yeah, so long-term goals for this are actually not for bicyclists as users of the bicycle facilities, but more for engineers and planners, that they would use it as tools to compare scenarios, to look at a bike network that's been proposed against the existing and try and get some quantification of how is it improving quality of service for the residents. So that's the goal of these tools, all these tools. Does that answer your question?
Somewhat, but is it also a potential
Yes.
outcome as well?
Yeah, it could be some, bicyclists like Walk Score and Bike Score that are online now. People are using those to improve, to decide where they want to buy a house and things like this. They type in their address and it gives them a Walk Score. So yeah, you could do the same sort of thing. But my effort has been for a tool that's useful to engineers and planners. Yeah.
Are any bike infrastructure elements, like bike parking, for example? If I can get the store, but I can't park my bike there, it may not be of value.
Yeah, the current way it's being calculated, no, but that certainly is something you could add to it. So right now, the way this tool works is you can give a point system to destinations, and if you want to improve the point system for certain destinations based on bikes facilities there, then you could easily do that. Yeah, that's a good question. Do you have a question too? I saw you raise your hand. Okay. All right. So great. So now I'll move on to this third tool. And each of these have just kind of progressively, over the years, as I've been working on these tools for different agencies to develop some sort of tool that an engineer and planner could use. And so then this was the next, another recent one that I worked on, estimating bicycle volumes. I'm going to give some background here. First off, who's familiar with the National Bicycle and Pedestrian Documentation Project? Can someone just sort of summarize what it is for those in the group?
It's an annual bike count that's done nationally, not everywhere, but it's a volunteer process. And they're 2-hour counts, and usually around the month of September. And it's a manual count by volunteers.
That's right. So it's a citizen volunteer count program, and this is just one. There's actually others that maybe some people are doing in their community. They don't even know about the National Bicycle and Pedestrian Documentation Project. But this group was initiated by Alta Planning and the Institute of Transportation Engineers. They actually recommend doing it 4 times a year. Most communities, or a lot of times, are unable to do that, so they do it 1 time a year, and you're right, often in the fall. They have a website, and on the website they have some instructions on how the citizens can go out and do the count, and they have some forms to fill out, and even some training presentation. So the idea is you've got citizen volunteers going out and standing at street corners, counting bicyclists and pedestrians through the intersection. So what happened, or the sort of the genesis of this tool I'm about to show you, is I was hired by a community to help with their count. And they'd been doing the count already for a couple years. And then they sort of said, you know what, and we don't really know what to do with the data once we get it. And so that was how this tool came about. So it's focused on that. It could be, the tool I'm going to show you could be used on other count techniques, even automated counters. But that's what I focused on. Just to give a sense of how these citizen volunteer count programs are happening in the state of Washington, they've been doing it for the last 6 years, and they've done it at 47 cities, and some cities more often than others. And they do it usually, like you said, 2 hours in the morning and 2 hours in the afternoon. And what happens at these counts, sometimes they're different cities, different jurisdictions have been doing this differently. Sometimes they'll count at a screen line that's just like maybe in the middle of a block, and they're counting in both directions. Other times they'll count like this, people going into the intersection, people leaving the intersection, and then a 12 movement count, which is what the National Bicycle and Pedestrian Project recommends, and I actually do too, which I'll explain why in a second. But I also will mention that I've seen, unfortunately, sometimes in the same city, people confusing what they're supposed to do, and I've seen counts like this, so that can be problematic. Why would you ever just do 2 counts? Well, the one reason why sometimes communities do that is because they add on, well, you got any guesses what they might be adding on there? Since they're only counting 2 things, what else might they do? Yeah.
You can pick up like characteristics of the rider.
That's right. Yeah. So often a screen line is associated with something like male, female, helmet, no helmet, child, adult, or something like that. So that's maybe the advantage of screen line. But I actually think that personally that the citizen volunteer count program shouldn't focus on that, but instead focus on this, and I'll explain why here. The question again, the question that was posed to me: how can citizen volunteer count data be used? Well, let's just hear some ideas of what do you think? How can these? So think about this. You got people. They're trained, but they're not professionals. They're on the street corner. They've counted for 2 hours. What are we going to do with that data?
How safe people feel if they're wearing helmets, if they have young kids in their part of bikes, or how fast they're going. So
in a way, I'm kind of posing a trick question here, because I'm wanting to think through some things, and you're going to. So the communities that I work with 4 communities in Idaho, and they had all kinds of wild ideas. Oh, this is. Let me just give you one example of a wild idea. Oh, this is great. Now we're going to be able to compare against other cities. And we'll show Boise that we're better than them with bicycle and pedestrian. But can you do that? Can you do a city-to-city comparison with the... So remember what's happening. You just got people sitting on a corner counting. What if Boise only counted at 4 intersections and you counted at 15 intersections? So there's no... You can't do that. And I heard about 5 other things that these cities said they were going to do that they can't do. And I'm not really sure if you can get any sense of safety just by counting people. So, but you got another guess?
Well, you can look at year over year changes in counts and compare it to whether you improved infrastructure or what kind of infrastructure you put in the area.
Yeah.
Attracted new riders.
So trend analysis, year to year. That's another common thing that I've heard cities say that they're going to do. Unfortunately, I don't think you can do that either. Krista, why would that probably not work?
You maybe have different locations, you have different volunteers, you have all sorts of things that are changing.
See, the problem is that it's just a snapshot. It only happened for 2 hours. So we don't know if maybe there was a mother's group that went by this one year and a huge crowd, and then the next year there's like they didn't go by. Or maybe there was just a meat sale at the grocery store, so everybody was going through there, right? So it's actually difficult to do that with just a one snapshot. So I actually would argue that that's not. Now, I'm not saying this is impossible. I'm just saying I think that that's difficult. Safety analysis is going to be difficult. What other things?
Would just using the volunteers free up some time for actual employees to do other stuff?
You know, in the end, these citizen volunteer programs, which are like a phenomenon across the country, they're happening all over, and in some ways, kind of that's what they're good for, is getting excitement in the citizenry, giving the, I've never thought of that one, freeing up the time of the city workers so they can do something else. But that's kind of what they're good for. And it was, the cities I've worked with, a huge success in terms of citizen engagement. Suddenly you got people out there saying, oh, this is really great. You know, it makes them aware, their eyes on the street, and thinking, yeah, we should improve biking. So I think it is a huge success there. But the question is, can it be something more than just that? I mean, couldn't we just have a movie together and talk about bikes? And do we have to have them out there counting? So cities are collecting this data. You know, I showed you all the cities in Washington have been collecting it, and they're not actually doing much with the data. It's because it's kind of hard. What do you do with that? You've just got 2 hours of counts. Any other thoughts? Yeah.
You could use it as a basis, like on a multi-use trail, for looking at like needs for a bicycle signal, at least as a starting point.
Yeah, and so I think in the end, these are great for starting points. You know, begin to say, all right, there's high traffic here. Like, you know, I've heard one person say, oh, we're going to use those for traffic signal timing. Nah, I don't think so. 2 hours, that's not going to be enough data. But maybe it's a start to say, oh, now let's go back and do a more thorough study of that particular intersection so that we can do something like a safety analysis or a traffic signal timing or something like this. Now, what is unique about this compared to, so those of you who might know about bike and ped data collection, there's like this kind of almost a debate about automated counters and human counters and like the advances and will we ever get there. Well, one of the things that I think human counters, these citizen volunteer programs really have an advantage of is that it's a snapshot, so that's what I put here, a snapshot of a large area all at once. Now, in this community, there was 26 locations, and a community this size is not going to be able to afford 26 permanent counters. But they can have, on this annual basis, a snapshot for volumes for a whole area. And so that's the thing that I think is the real advantage of what could you use this data for, where you're just getting a snapshot for that 2-hour period at least, and you do that every year, and you begin to just grow your snapshot of what's happening. So like, here's one place that did it, and they had 80 locations. And that's really amazing when you think about it. Simultaneously, there was 80 people counting at all of these intersections. So the community that I live in, the city of Moscow, in this same period, for counting cars, in cars they lay out tubes, they've done about 250 locations. But that's rotating the tubes around every couple days. So even in a way, this is cooler than that because it's a simultaneous count all at once.
My name is Nate Rochester. I'm wondering if you're using that snapshot, if you're actually wanting to get some use of the snapshot rather than just having it for the sake of having it, you want to compare it to itself, right, to other years, other 2-hour periods, other snapshots. And if you're doing that, then wouldn't it be pretty necessary to have the same number of locations year to year?
Yeah, again, I think anytime you're going to start doing an annual trend analysis or something, you're going to have to make sure you're at the same locations. You're probably going to want a permanent counter that's also there, that's able to show that you're able to compare with adjustments to what's, so you got the permanent counter that's 365 days a year, then you got the snapshot that's happening. Then you can begin to start doing some trend analysis. But a lot of communities just don't have permanent counters. The citizen volunteers changed year to year and things like that. So just real quick, I'm going to show you what it is that we're doing, and then maybe I'll come back to your question. So what we do is, I'm going to give some more background on travel demand modeling. So, and I forget, it's mostly engineers and planners in here, right? Transportation folks. So, travel demand modeling, there's sort of 2 ways to do it. One is like a multi-step behavior model, like a 4-step model, pretty complex, sophisticated, and to date, techniques to do this for bicycling and pedestrian have not been really great. You're modeling just so many things at once, and it's, we've come a long ways with cars, and we're getting there with bikes, but still, it's not really great. Then the other way to do it is what's called a direct demand model, which is where you estimate the volume on a facility based on characteristics, perhaps with a regression equation like this. And so you say, okay, I know this street is this. It's an arterial. It has a bike lane. Maybe it's a distance to PSU campus or something. And so this is the volume I would expect on it. So what we did is we kind of did a mix of the two. And I'm going to explain that here. I'm not going to go into a lot of detail of the theory behind it. I'm just going to use sort of general terms. But the idea is we're going to take these observed counts, and we're going to spatially extrapolate them through the network. And the way we do it is, do you remember the word topology, what that is? That's like the connections of the street and how they're connected. So basically, in a way to think of this, is we think of the street network as like a stream system, a river system. And all the streams are flowing into each other. And these can be considered like gauges in the system. And so they're observing a flow. And then we correlate the flow that we observed with the expected flow throughout the rest of the network. So how do we get that flow? The way we do it, well, I'll go to a video on it, which I think will explain it pretty good.
In this video, we demonstrate using our GIS tool to estimate bicycle volumes. We have opened ArcGIS with all the necessary input files. I'll turn off the base map to look a little closer. We have the observed counts at every intersection. If we zoom in, we see that this intersection had 120 bicyclists passing through it in total, and this many bicyclists doing the 12 movements of the intersection. These points were observed by citizen volunteers during the National Bicycle and Pedestrian Documentation Project. The other input files that are needed are the residential parcel file and the non-residential parcel file. The tools can be accessed from a USB or from anywhere. I have them located just on my C drive in a folder called Bicycle Volume Estimation Toolbox. There's example data in the folder, some necessary files for the tool, and then the toolbox, which has some preparation tools for the network, and also the tool will be demonstrating the Estimate Bicycle Volumes tool. The tool interface indicates the required input. The first input are the observed counts. We'll do the analysis for the morning observation. Next, we need the parcel file for the origins. Since it's the morning observation, we'll use the residential parcels. Associated with the residential parcels, we need to have a multiplier, which is a field within that shapefile. And then for the destinations, we'll use the non-residential parcels and the associated multiplier. Next is the bikeway network, which will be the street file, and then an impedance or route preference field. We'll output it as AM bike volume. We'll overwrite the existing one that I already did and run the tool. Right now it's preparing the data to locate all of the parcels to the network, and now it's calculating centrality. Centrality is a network analysis metric which is a count of the number of times that a link is used if there's a shortest path from every node to every node. In this case, from every residential parcel to every non-residential parcel, the number of times that a link is used. This part of the algorithm takes the most time. I will fast forward it for the video. The tool took 2.5 minutes to execute. This is the estimated volumes. We can highlight links to look at the volume. We'll open the table. This link has a westbound estimated volume of 59 bicyclists and an eastbound estimated volume of 17 bicyclists. If we zoom into an intersection and highlight the links, we have the eastbound left, which is estimated to have 13 bicyclists, southbound right is estimated to have 38, and so on and so forth. Here we have northbound left, eastbound right, and here we have southbound through and northbound through, 10 and 24 bicyclists.
Okay, so that was the next tool, and I could certainly go into some detail on how it works, but essentially what it is that metric called centrality. Centrality is a network analysis thing that's a measuring topological flow. It's just saying if we were to go from every residential to every non-residential parcel on what would be considered the preferred bicycle path, and I actually used some of the work that was done by Joe Broach here on bike preferences, Joe and Jennifer Dill, their paper. And so anyways, the shortest path, how many times is a link used? And the number is actually a huge number. But if we correlate that to the observed count, that's how then we're able to extrapolate throughout the network.
You had some pretty sophisticated topology on that map. Is that something that a lot of jurisdictions have?
Yeah, most cities have a street network. That's all it is a street network.
Yeah, but it looks like turns are all.
Yeah, actually my tool does that. It just makes it. So you just give me a street network with full intersections, and it blows them out into a 12-movement intersection. But topology is not, you're right, the topology is, it sounds like you're familiar with GIS, and you know it's hard to get a good street network. Luckily nowadays, like even Esri, the makers of ArcGIS, they give you, you can get a street network for the whole North America now. You know, whether it's up to date, I don't know. But a lot of cities do have a street network, and sometimes they need work to get their topology correct. It can be very time-consuming. Yeah, I agree to that. But the intersection that you see, that's my tool makes that. It automatically generates that. Yes?
So what I was going to ask you earlier is, are you potentially, or something you might do, is use it to plan designated routes for bicycles based on this early preliminary feedback and if you changes, it could be helpful. But in terms of use it for engineering, I could see it as being a useful design tool.
Sure. Yeah, again, this tool, again, is the idea is that you run it, you get your estimated volumes, and then you run it again under a different scenario with different trails or different bike network and everything. And that's actually a good lead into my next tool. First, let me just finish off here. So the idea is that you spatially extrapolate the morning count, you spatially extrapolate the PM count, and then you use some factoring that maybe you've developed with some permanent counters or something that are then able to factor those to get what's called an annual average daily bicyclist, which is like a full day count for the network. And so then you have that. You have the estimated AADB, annual average daily bicyclist, for the whole network. And then could you do that under a different scenario and see how that changes? I guess I'm not ready for my next tool yet. I'm still finishing off this tool. So scenario planning. The city of Moscow is thinking of putting in a new residential area here. The other thing they're going to do is this is actually not connected because there's a creek right there. And for like the last 10 years, they've debated whether they should connect that. You know, a lot of citizens don't want cars coming through, so they don't want a car bridge. But the bike ped community wants a footbridge, and so it's just been debated for, you can imagine how these city councils go. And there's schools along there, so that's part of the debate. Like, do we want a lot of traffic going up and down, but it's our best east-west? Well, anyways, what we did as an example is we looked at if we were to build that, how would it change expected bicycle volumes? And so here is that street, which is called 3rd Street, and then this is every intersection building up. And under the current conditions, there's not too many bicyclists, but we expected an increase in 200 bicyclists per day right at the start, and then all the way down at the end, an increase of about 150 bicyclists. So that's an example of how you would do that scenario analysis with this tool. Okay, so then the next one, which is also kind of a scenario analysis, is a tool that my most recent thing we've been working on, which is to assess dangerous situation exposure. Let me give a little background, just one slide, on accident analysis for bicyclists. Is, if many of you may know, is very difficult to do. One, because there's not a lot of data on bicyclist accidents. Well, one, we don't have a lot of volume data on where bicyclists are bicycling. Like I've already said, you know, that's sort of what motivated the National Bicycle and Pedestrian Documentation Project, is because it's some sort of, let's do something to start collecting more data. We just don't have a lot on bike and ped. But we also don't have a lot of accident data, because lots of times bicycle accidents aren't reported. There's one paper that said that up to 89% of bicycle accidents are never reported. Usually it's only if they're fatal or if there is an injury and it was an interaction with a car. So it's very difficult to do bicycle accident analysis. And so we decided to take a slightly different approach. And what we did is we wanted to define what we called antecedents to accidents, dangerous situations we call them. And we went through the literature. We came up with a list of 24 what we call dangerous situations. And we said, okay, we might not be able to see where accidents are happening, but we can see where dangerous situations are. And so we defined these. I won't go through them all, but this is the name, the brief description, and then some references, and this is just a table from a paper that we're writing. But some of them are things like mixed cycling in harsh traffic, or separated cycling. Nick's this morning, his thesis was separated cycling. Dooring, where you get doored on your way through. So these are all dangerous situations. Some that maybe you've heard of before, the right hook. Who knows what's a right hook? What's a right hook?
It's when the bicyclist is continuing straight and a motorist to their left is making a right turn and turns over the bicyclist, and they
Yeah.
Yeah. Did everyone see that?
So in the bicycle world and in bicycle accident, it's a hot one, and mainly maybe because it has a cool name, the right hook situation. So you hear about it a lot, how it's a dangerous situation. Well, we can just look at, well, where's that happening? Where is a place where there are a lot of cars that are turning right and a lot of bicyclists going straight? That's a right hook situation. And so then, and we don't. This didn't really have a name before, but we're calling it the left sneak. It's the same idea. And we want to have a catchy name like the right hook. So the left sneak is just the idea when you're bicycling and you want to get over to the left, you have to actually do two dangerous moves. First, you have to weave over to make the turn, and then you often have to wait for oncoming traffic to sneak in. So you're sneaking twice, actually, through the left sneak. So what is that? That's a situation where there's a lot of bicyclists turning left with a lot of through traffic of vehicles, either oncoming or adjacent with you. Wrong way riding, so we had this list of 24. So then the idea is then the next step, or the first step here, is to define some metrics for this. And at this point, I don't think that we can begin to make national metrics or anything, but maybe at a community level, through some public involvement program, you start saying, well, what are the thresholds? When would we say that this is a dangerous right hook situation? Because every intersection is an intersection. There's people turning right and people going straight, but there's only maybe at a certain volume of cars that we'd start to say, yeah, that's dangerous. And so the first step is to have some process that you start to define this. So this is like, maybe dooring happens when there's a part. So dooring, again, is the one where you're biking and parallel parked cars might open their door on you. Well, we can know oftentimes it's communities know the percent of turnover on a segment of street, like how often cars are coming in and out. Businesses usually like to know that kind of thing too, but also just for parking reasons, we often know that. So maybe at a certain turnover rate of parking, we could say that's a dooring problem or just a parking maneuver problem. So you can begin to try and define each of these dangerous situations in terms of some threshold. So we did that, and then we created a GIS tool that just coded that. It just coded a bunch of thresholds. And our case study was Bellingham, Washington. And Bellingham has a new master bike plan. And this is showing both the existing conditions and the new master bike plan. So the dotted lines are the proposed. And so we've got blue is for bike lanes. So dotted proposed bike lanes, and then green is for trails, dotted proposed trails. So we've got two scenarios, the existing and proposed. And we ran our tool to get the bike volumes on both of them. And even though this is like far away and you can't see it very well, you can see that there is something different here on the proposed system. And so let me give you another graphic that will show some of the differences. This is showing the change in annual average daily bicyclists between scenario 1 and scenario 2. And what it's showing is, for example, let me just highlight down here this inset, that a lot of bicyclists would not be going on this green right here is an arterial road, street, and there is a proposed trail that the city of Bellingham is proposing to turn into more of a bike suitable trail out here. And what our model showed is, well, if they did that, it would probably move the bicyclists off of that arterial onto that trail. Right, so that's a very clear example of how it's just a rerouting, and we mentioned that earlier, that you create a new network, and because of route preferences, people would just ride in a different location. And that's happening throughout the whole network. And so when we run this analysis that just zooms through the whole thing, okay, where's the threshold of where there's a certain car volume that's turning right and certain bike volume that's going straight? That's called a right hook. So where's that happening and how often is it happening, right? And so this then is that output. And it's just showing the number. This is annual number. And there's a lot happening in this graphic, so let me just maybe just highlight a couple. So here's cycling and mixed traffic. Scenario 1, 666,000 bicycle miles traveled under that condition. And then there's a 59% reduction in that under scenario 2. So the idea is then this is just something to have at your city meeting, in the public town hall meeting that the planner and engineers come in. It's just some more information to help make decisions about should this new master bike plan be enacted and what parts of it should be enacted, is you just start to look at these tables. So here, that one, the right hook, it was a reduction in 5% by changing, because basically now the model is showing that that situation is not going to happen as much where there's a high volume of bicyclists going straight with cars turning right. Another thing that the tool does then is it also highlights then where are those happening. So here's the right hook exposure, and here's all the intersections. The bigger means that it's expected to have a higher exposure than the smaller ones. And you could do this for the other ones, the left sneak and the dooring and everything, and just sort of highlight it, color code it, or whatever, to be able to use it in your decision-making process of what should be done. Some future work on this. For those of you who know about accident analysis, what we'd really like to do is have what's called a safety performance function. Has anyone ever heard of that? Does anyone know what that is? Could you just say briefly what it is, gentlemen?
Joe Merrick. It is, let's see, how best to describe it. It's basically kind of an adjustment factor to look at crash reductions by applying a different type of solution.
Yeah. Okay. So what Joe mentioned is the combination of these two things. So the performance function is this equation that you plug in some exposure or some conditions, and then it'll be the expected number of accidents. So we haven't done this, but this is future work. What we'd like to do is say, well, if we have this right hook exposure, we put this into an equation, and it's going to give us the expected number of accidents. And then, as Joe was saying, and then there's usually along with it some cross modification factor that says if, for example, and one for the right hook is this green painting that you see a lot here in Portland, that's to help mitigate the right hook situation. And it's just another visual cue to the motorist that there might be bicyclists there when you're trying to turn right. And I don't, this number I've made up, but if we can get to this point, that's where the goal is to start saying, how can we reduce the expected number of accidents with all of these cross modification factors? And there actually has not been very much work done on this. Actually, Christian Norbeck's one of the few that have actually developed some safety performance functions for bicycling. So, in conclusion, these tools that I've showcased today, they take commonly available GIS data, street network, parcel file. Most communities have a parcel file of the land use, and then a street network, and producing pretty good results. They're all sort of in an academic state still, because they've only been tested for a small community, and the goal now is to start testing in other places. And so we've done Bellingham, and now we're going to do Seattle and Minneapolis. So that's where we're at, and I can take questions some more. We'll start here.
Yeah. Concerning bikeability, you mentioned that you kind of think that expert opinion about specific areas might actually be more beneficial than the analysis. Did I mishear you on that?
Well, I can just say in general, I think public opinions with all of these tools, at the beginning and the end, my PhD actually was a lot on public involvement, so I'm quite an advocate for it. And although I am an engineer and I love the math, I think there's limitations to all the equations. So actually I showed 4 tools, and all of them, there's a place for public input on. So suitability, defining what they consider suitable, and bikeability, what maybe the point system you want for your destinations, and so on and so forth. So yeah, definitely. This young lady here.
Last name is Ida. So I was wondering, like, when you're doing this sort of safety GISing, if you had access to like data on where accidents occurred, so you could kind of like, so you knew what the potential for accidents were, but you could also know what did occur.
That's a great question. So this project was done with in partnership with Washington Department of Transportation, and they recommended Bellingham because they said there's a lot of data there. So Bellingham gave us all their accident data, and we mapped it out, and it was a lot. but it's still not enough. The thing that when you do these accident analysis, you actually need so much data in order to get your statistics right that it's really difficult for bicycle. With car accidents, there's so many car accidents that happen in a year, you can develop those statistics more easily. And we probably could have, even with limited data. There's a good reason to attempt that. But we decided to do a different approach and say, let's just say, look, so all of those metrics of the dangerous situations, to be clear, that's not saying that a right hook is going to happen or has happened or anything. It's just saying that situation is there, and it's just an index of that. And so, yeah, we didn't go as far. But that would be the next step, is to start saying, well, now how do we compare that with observed accidents? Hasn't been done yet.
So for the safety analysis tool, or the dangerous situation analysis, I'm assuming that includes on the street network, you've got to have the volumes and speeds, and I imagine those are inputs into some of the factors. Were those available from the city of Bellingham, or how did you get that sort of data into your GIS?
Yeah, so the only things that were needed was the bike volumes, of course, and then on the other side was width of lane, speed limit. We just use speed limit. I mean, you could maybe use like 85th time per speed or something, but we use speed limit, and then volumes, AED volumes. And the city of Bellingham has a pretty good AEDT map, and we just we use a travel demand model to extrapolate that and to get it everywhere. But yeah, so you would need volumes. So you need some car travel demand model that gives you car volumes. Yes?
When you're doing the scenario analysis, how are you controlling the total AADB? Are you using the same scaling from the centrality numbers, or are you controlling for total BMD?
Yeah, so the AADB that was calculated was through the same technique, the centrality technique. And so then it was the AADB for the given scenario, and then you use that equation, maybe if I'm understanding your question, so you calibrate your model for the status quo, and then you apply that model for a different scenario. There's no way to validate that, of course, because it's some future unknown scenario, but you just, that's... Yeah. That's right, exactly, yeah. Which is, the typical way to do some sort of scenario analysis, because there's no way to validate something that hasn't been built.
Matthew Downey, I was wondering, do you think your tools, as is, will translate well from Moscow to Seattle? Do you think you're going to have to test them?
Yeah, I don't know. That's what we're looking into now. So we did Bellingham, which is a bigger city. Moscow's certainly a small city. It's also self-contained. It kind of doesn't have a lot of through bicycling, but there's ways that we've thought of to address some of those issues. There's not a lot of recreational cycling. I will say we tried this with pedestrians, and it didn't work very well. So we'll just have to see. It's at an academic level.
There is a lot of interest online and reading online questions. I think a lot of interest whether the tool is available for public.
Oh yeah, that's a good question.
Yeah. So the tools, yeah, they're like I say, they're under development. So there's not like great help documentation or anything like that. And what would be great is if someone online or some firm would like to give me money to develop it and advance it, or better yet, I just pass it off to like Kittleson or something, and somebody takes it over and makes it a marketable. I mean, in academia, we're not really so much in the business of developing a product that we're going to sell, but we maybe get it incubated and started and hopefully break it off. But yeah, if someone's interested in the tools, it's all written in Python open source, so they can modify it and change it how they will. And I've given some of the tools to. The first tool that I showed is available. That was made for Idaho Transportation Department and the University of Idaho, and our Transportation Department has an agreement on how things work. So you have to buy it for $50. It's on a disk, and you can get that disk through the website. This most recent tool is sort of brand new, so someone would just have to contact me. I also have here, because I thought people would be interested, so I wrote a paper on every one of the tools that I showed today, and you can find that as well for more information on how they all work.
My name is Gregory Kirkland, and I'm just curious, in your experience when you're collecting all this data from the citizen volunteer deal, what was the reliability on that, and what kind of factor safety might have you used to account for skewed counts?
Yeah, that's a great question. So to my knowledge, there has not yet been a study on citizen volunteer count validity. And we're kind of doing one right now at the University of Idaho. But I think a full study should be done because case in point, the communities that I've worked with, you've got teenagers that are doing it, all the way to like concerned citizens that are retired and in their 70s that just want to sit out there and count. So there's a whole different level in what can they handle in terms of counting at an intersection, which, by the way, goes back to why I think that the critical thing is to get all those movements. I don't think I actually mentioned that. So you could do a screen line where you just get 2 things, or you could do all 12 movements. And for my tool, since you want as much data as possible, I think getting the 12 movements, but don't get any of that other stuff about male, female, helmet, no helmet, because it just complicates things.
I had a similar question about the reliability, but assuming that you can't get the volume reliability that you're hoping for, what are your other options for getting this massive quantity of volume for the bikes?
I think we're a long ways from an automated technology that can get a large geographic area count. It'd be great, and I know there's people out there that think that we're getting there, and soon we will maybe have for bikes tube counters all over a city that are getting lots of data. But at this point in time, I think there's a real value to this citizen involvement because, like that one community, 80 locations all at once, that's pretty good. Even in the car area, for cars, we sometimes don't get that much geographic spread.
What's the cost for a bike counter? I'm just curious.
I think so one of the premier companies is Echo Counter, and they're at about $3,000, I think. Is that right? Yeah, there's like different, if you want a 15-minute increment or you want, different increments of how often it's giving it, whether it's sending the data to you over the internet or over like the phone line, or whether you have to go to the machine and get the data. So there's all kinds of options. So it'd be $3,000 to $5,000.
Have you looked at using analytics on surveillance cameras to get counts?
Yeah, there's a lot of people who have done that. Yeah, there's video technology for counting. There's issues with that. Don't need to, that's a whole other topic. But there's issues with automated counters. One's called occlusion. That there's a group of people and you don't know, was that just one big huge person or was that a couple people? So there's issues, but they're working on that, and they're definitely getting huge strides. And I think that they're, I'm saying that I think technology will be there one day, but right now it's not. Yes.
There's one more question from the online audience. Can you clarify if Tool 2 integrates with Tool 1 such that scores use a BLOS weighted network distance for calculating scores?
That's kind of a tough question. I don't know if I got it all.
Yeah, but
so,
do they integrate, I guess, is the general question.
Did someone else get the question? Maybe you can repeat it again, or what? I'm sorry, I didn't quite get it.
Can you clarify if Tool 2 integrates with Tool 1 such that scores use a level of service weighted network distance for calculating your score?
Exactly. Great. Okay, thanks.
Now I got it. I didn't hear that. Yeah, whether Tool 2 is related to Tool 1, and actually I kind of built them all toward each other. So yeah, Tool 2 is using bicycle level of service. It could have used some other thing. It could have used the bicycle stress level, which has been developed by Peter Firth and his team, or somebody else. It could use any measure. But in my demonstration paper and in what I showed, it was using bicycle level of service.
Before we thank Dr. Lowry for this great talk and all those tools, I want to announce that the seminar next week is our very own Professor Robert Tini giving seminar number 394, Transforming Transportation Through Connectivity. So thank you, Mike.
All right. I'll just say in closing, this is the trail of the Coeur d'Alene. It's a great bike trail up by my house. If any of you want to come up to Moscow, we'll go for a ride out there.
Is that yours also?
Yeah, this is my daughter, Hannah. She loves biking as well, so she came with us.
Yeah.